Hello everybody, and welcome back to the second session of the conference today. Having focused this morning on key bands for 6G, we're now going to be moving on and looking a little bit more at licensing models and looking at how access to those bands is granted. So it's obviously something that was covered or at least touched on in some of the discussions in the first session, but it's going to be a key issue, of course. So we're delighted to now have a session that's going to be focusing specifically on these issues of licensing, looking at the role that spectrum sharing can play and how licensing models may evolve. So to explain more and to introduce our speakers, I'm now delighted to welcome to the stage Elena Scaramuzzi from Calon International. Elena, welcome. Great to have you with us. Really looking forward to this session. So without further ado, I will pass over to you and leave you to introduce our speakers. Over to you.
Thank you, Dan. So thanks, everybody. I'm Elena Scaramuzzi from Calon International, and I'm very happy to moderate this session on 6G licensing models and sharing models. The discussion in this case will be with four key panelists, and it will really be about the sharing models for spectrum for 6G, what bands might be envisaged, which one might be expected in the future, and also about the technological aspects and the lessons learned from previous experiences in 5G, and see what we might really build for 6G. So Calon International is a regulatory, let's say, intelligence company, and we recently published a paper on 6G. So I'm delighted here to invite the four panelists today. So we will discuss the perspective from the regulatory standpoint with the regulator of COM, with Chris Woolford. We will have the academic perspective from Monisha Ghosh, and she's from the University of Notre Dame in the United States. We will have with us Dave Wright. He's from Hewlett-Packard Enterprise, and he will bring the industry perspective. Thanks, Dave, for coming. And last but not least, we have Liu Guangji from China Mobile Research Institute, and Liu also will be their industry representative who will contribute to this panel. So my suggestion, since time is limited, is that we will have, let's say, 5 to 7 minutes presentation and address by each of the four panelists. And that will leave a bit of time for the discussion and for questions if you have any. And so I will. I really hope to have a very good discussion today. So I would start from Chris, the regulator's perspective. And so Chris, how do you see 6G and the role of sharing and the licensing and the new business model coming up? So what's your perspective and the Ofcom perspective?
Okay, so thank you very much, Elena, and good morning, good afternoon to everyone. So if we go to my first slide, actually, go to the next slide, Dan. I'm going to talk a little bit about sort of the spectrum perspective. But before I do that, I mean, I think my first point is that there are many factors that we need to consider in terms of meeting the needs of 6G in the future. Now, undoubtedly, spectrum is one of those, but there are other factors. There are things like the way in which networks are going to be deployed, denser networks of the future. The evolution of technology has been astounding over the last decade or so, and that will continue, I'm sure. Business needs are evolving and changing, and all these factors interrelate and need to be considered. And spectrum is also there, but needs to take account of how those different factors interrelate with one another. And that's both in terms of the choice of spectrum bands, but also how we authorize that spectrum. So if we go to the next slide, in terms of sort of the regulatory perspective, I mean, networks are evolving. There's no doubt about that. And they are, from a regulatory perspective, we need to think about how those networks are going to evolve and how those networks are going to respond for the increasing demand and the change in business models. We can expect to see denser networks. We can expect to see more players involved, possibly some smaller players than we might have done in the past. Lots of interest in private mobile networks and lots of interest in spectrum sharing. And we'll talk about that over the course of this panel. Also, the integration between different types of networks, including terrestrial and non-terrestrial. Some really interesting challenges about how these networks are going to evolve in the future. And what does that mean for spectrum requirements? Well, we keep being told that actually we can expect some quite significant changes in terms of what it might mean for spectrum. Lots of interest in higher bandwidths than we've seen before. I mean, I've heard, in fact, I heard earlier today that that there's interest or reference to a new sweet spot between 7 and 20 gigahertz or 7 and 15 gigahertz or somewhere in that range. Lots of interest in that sort of higher mid-band spectrum. Also terahertz, very high frequency ranges, and also this idea of, say, of localized access, making spectrum available when and where it's needed, and the shared access that would need to go with that. However, I think it's also important to point out that some things are going to stay the same. I mean, we can expect demand for spectrum to increase from mobile, but also from many other services, including broadband applications like Wi-Fi. We also know that spectrum will continue to be a finite resource. So that congestion, that level of demand and for spectrum is going to become increasingly challenging. And also, I think when it comes to things like mobile, I would anticipate that mobile operators will continue to require a range of spectrum bands. Lots of interest in some of these new bands, but they are still likely to require a range of low, medium, and high frequency bands. So if we go to the next slide, and as I say, this sort of sets out there's a range of business models that we need to sort of think about in the future. And I think it's clear to me that there isn't going to be one solution that's going to fit all. We tend to focus on these conferences quite a lot on the right-hand side, which is the sort of the newer end of things, private networks, industry vertical, sometimes sort of thought about, you know, the sexier side, the innovative side of 5 and 6G. But on the left-hand side of the slide, I mean, it is important to point out that, you know, the MNOs are going to continue to play an absolutely key role in the delivery of mobile broadband going forward, in the delivery of 6G. I mean, that is how many consumers are going to access, you know, 5G and then 6G services. How MNOs go about refarming their existing spectrum, I think, is going to be absolutely key. And then in the middle, there's lots of interesting ideas about how we might access spectrum slightly differently in the future. Hybrid solutions, different business models. And I think the role for the regulator there is to ensure that we're not inhibiting, to ensure that we're not standing in the way of any of these innovative new solutions that may emerge, and that we are making spectrum and indeed the regulatory environment available so that those hybrid solutions can emerge. So if we go to the next slide, I mean, what does this mean for regulators? And I think, you know, my opening gambit is to say that it is really early days when it comes to 6G. I mean, we're not in a position yet to talk about exactly which bands or exactly how we'll make spectrum available. But what I think we can do is talk about how regulators are needing to evolve their approach to spectrum management in order to meet these needs of the future. So firstly, we need to be aware of how technologies are evolving. Things like 6G, things like new evolutions of Wi-Fi, things like the incredible evolutions on the satellite side of things, how these different networks might integrate together. What does the rollout of full fiber mean? And what does the implications of that for future spectrum demand? Secondly, we need to be aware of how innovation is evolving. A key role for regulator is to enable and promote innovation, and that rate of innovation is accelerating. I've spoken previously at conferences about what Ofcom has done to make spectrum sharing a reality in our spectrum sharing framework. We want to go beyond that. We're talking about spectrum sandboxes, the idea of making or giving opportunities for innovation in particular geographic locations or in specific bands. The idea of 3.8 to 4.2 is one we're particularly interested in, and we've made it clear to industry that we are very open to suggestions. However, we do want to put the incentive and the onus on industry to come forward with ideas for how they can use spectrum more efficiently, perhaps on a more dynamic basis. Whatever, we're very open to suggestions, and we would like to have that discussion with industry, but it does need to come from industry in the first instance, but we are very willing to engage. And then finally, and perhaps even the most challenging in some ways, is around better data for spectrum management. And I think this is absolutely key. We need to obtain more real world data, particularly if we really believe that spectrum sharing is the future. And personally, I think that is right. Spectrum sharing is going to be increasingly important. But for that to work, we need better data. We need better coexistence modeling. We need to ensure that our models are not based upon worst case upon worst case. I mean, too much of the time is a time sort of trying to resolve coexistence issues, is trying to resolve disagreements about the assumptions that go into some of the models. We need to be better at actually being realistic in terms of our planning assumptions. We also need to understand more about the real world performance of different technologies, things like active antenna systems. How do they operate in the real world, and what does that mean for our spectrum management planning? Also, receivers is another area. So I think that's one of the key fundamentals if we really do want to promote spectrum sharing, to have better data. A quick overview there, I think, of just some of the key areas that we're thinking about. As I say, 6G is still very much in its early stages. But those are sort of the perspectives from a regulator in terms of how we're evolving our thinking in order to get us to the environment which will see deployment of 6G. I will stop there. Thank you very much.
Thanks a lot, Chris. Very interesting. Now, I think before taking on board the questions, I would let Monica Ghosh to have her own views, to present her own views about 6G perspectives. So, Monica, the floor is yours.
Thank you very much. Thank you very much, Elena. Thank you for inviting me to this workshop. I'm Monisha Ghosh. I'm a professor at the University of Notre Dame. I'm also the Policy Outreach Director of a new center called SpectrumX at the university. And I also co-chair the FCC's, as the Federal Communication Commission in the US, the Working Group on Advanced Spectrum Sharing. Next slide, please. So we've seen this information many times in the past 2 days. I won't spend too much time on it, except to point out, which many people have pointed out, is that the definition of mid-band has been shifting. It was always sub 6 gigahertz. 1 to 6 was considered mid-band. It became 1 to 7 when we had the recent 5.925 to 7.125 gigahertz band come online. And now there are already discussions about denoting the band between 7 to 24 as FR3. That is very interesting. It also poses a lot of challenges because, as I'll talk about later, is that band is not empty. So it's full of existing allocations. And so the challenge for spectrum regulators and for researchers is to figure out innovative ways of being able to share with incumbents there. High band, greater than 24 gigahertz, was one of the new bands that was used for 5G in millimeter wave. Deployments in millimeter wave are increasing in the US. A number of carriers have been deploying millimeter wave since 2020, mostly in dense urban areas. But the performance in real-world conditions has not yet met the promise of theory. It's still early days, but it is clear that millimeter wave, higher frequencies are going to have limitations. And the question about are they a truly mobile cellular technology is, I think, still unanswered. The problems are due to propagation, obstruction, body blockage, and more importantly, this doesn't go through walls at all. So you really cannot serve people indoors from millimeter wave outdoors. And we've also recently done some research which shows that your handsets are very constrained. So when you have millimeter wave, you need beamforming at both ends. On the handset side, there's only a very limited number of antenna array elements that you can squeeze in. And so the performance gets limited. There's been unlicensed spectrum that has come online. In the US, the full 1.2 gigahertz was allocated to Wi-Fi. Allocated to unlicensed. That does not mean it's only Wi-Fi. We fully expect that cellular systems will take advantage of that huge amount of spectrum using modalities like 5G and RU, just as LAA was used to aggregate additional bandwidth for LTE. And so we don't talk about that spectrum much, but carriers need to start looking at how they can leverage that band as well. There's new spectrum being considered in the US, 12.2 to 12.7. But that has to be shared with satellite. That's an ongoing proceeding. And above 95 gigahertz today in the US, we have something called the Spectrum Frontiers, where you can deploy systems there on an experimental basis. Next slide, please. So the question which has been asked throughout this workshop is, where will it be? Where do we think the spectrum for NextG will be? Midband is still the most desired. But as I said, almost all of it is allocated. And I'll talk a little bit more about how we can share there. People tend to think that in the high bands, there's nothing to share with, but that's not really true. There's plenty of bandwidth. But the problems of millimeter wave are compounded. And actually, most of that region is allocated today to passive scientific uses, which also need to be protected. As a community, as a society, we want to, have the advances that we recently saw with the Event Horizon Telescope, which operates at 230 gigahertz. That is what gave us that beautiful picture of the black hole. So passive systems are actually very, very difficult to coexist with because their receivers are so sensitive that what would be noise to any other commercial system shows up as signal to them. So it is very, very difficult to coexist with passive receivers. Thus, as we move forward in this new domain for 6G, we should keep in mind that spectrum sharing and coexistence is not just important in the midband. It is as important, if not more so, in the higher bands as well. Next slide, please. So we often hear the terms sharing and coexistence used sometimes interchangeably. And in my mind, I have tried to sort of separate what I mean when I say sharing versus coexistence. So for me, sharing is between unlike systems. These could be co-channel or adjacent channels. So some examples from the past is you had TV white spaces where broadcast TV was sharing with personal portable Wi-Fi-like devices. Right now in the US, you have CBRS, where you have cellular systems sharing with DoD radar. C-band radar altimeter was an adjacent channel sharing issue where you had radar altimeters and bands adjacent to cellular. And in this kind of a situation where we're talking about sharing, the RF interference levels are the primary metric of interest. You really want to keep this out of band interference down or manage in-band interference by exclusion zones or other means. Coexistence, to me, again, is between like systems. So for example, Wi-Fi has been coexisting with Wi-Fi in the unlicensed bands and other systems like Bluetooth and Zigbee and everything else that fits into that band. We've also had Wi-Fi LAA in the 5 gigahertz, and we think we're going to see Wi-Fi 5G and RU in 6 gigahertz. We are also having this very new model via private 5G networks where cellular systems are beginning to coexist in co-channel and both adjacent channel. And in this case, where we're talking about coexistence, you also need to have a very good understanding of the protocols that are being used for these different systems to access the medium. So RF levels are still important, but so are the MAC protocols that are being used. Next slide, please. So there are a number of challenges, and many of these have been highlighted in the past. I think Chris mentioned that we shouldn't be doing worst case. We should be looking at an probabilistic way of dealing with interference. But most rules, at least in the US and I think around the world too, consider only worst case interference to determine protection thresholds. This is very inefficient because we are trying to set rules which protect a probability of interference, which may be 0.001. A prime way of sharing today is via databases, but those are very static. The exclusion zones that we determine are based on worst case and based on propagation models that have not been updated in like 50 years. And so we end up with very overprotective systems. In CBRS, we've used sensing along with databases, but that has its own problems because now the sensors themselves need to be protected so they can sense. So now you have whisper zones, which again do not allow you to use spectrum. So there are other alternatives for sharing which you should consider, and some of those are there. Use lower power, but only indoors. That's what we did in the US in 6 gigahertz. Use some of the degrees of freedom of massive MIMO to do spatial rejection. And most importantly, and something that we don't talk about a lot, is that the 5G system is not designed for sharing, and we have to address that. Next slide, and that's my last slide. So clearly, there's a lot of research that needs to be done. It has to be collaborative between the academia, government, and industry to take spectrum sharing to the next level. And to address this need, the National Science Foundation in the US launched Spectrum X. It's a collaboration between 27 universities and many researchers. We also have a memorandum of understanding between NSF, FCC, and NTIA. And the goal and the center vision is to basically move spectrum management into the next generation. And I'll stop there because I'm running out of time. Thank you very much.
Thank you very much, Monisha, for the very interesting presentation. So I will give the floor now to Dave Wright from HP Enterprise. Dave, please, the floor is all yours.
Wonderful. Thank you, Elena. Thank you, Forum Global and Dan, for the opportunity to be here. So Hewlett-Packard Enterprise, we actually have interest really across the range of spectrum regimes, if you will, at least terrestrial. So certainly a rich heritage in Wi-Fi with our Aruba Networks division. We also supply a lot of key components to mobile operators for both 4G and their 5G networks. And more recently, we've been providing private cellular solutions predominantly to enterprise customers that use spectrum bands like CBRS or some of the bands that are now being locally licensed. So that's a little bit of background on me. I do happen to also be president of the OnGo Alliance, which is the industry org sort of leading the charge for CBRS and 3GPP technologies operating in shared spectrum bands. And I appreciated Manisha's point that, historically, 3GPP technologies have not operated in shared spectrum, so there is some work to do there. Fully agree with that point. And then finally, I'd note that I also serve on, in the US, the Department of Commerce. They have a Spectrum Management Advisory Committee, which advises the federal spectrum managers in the US on sort of the commercial industry needs. Next slide, please, Dan. So always important to kind of define something before you discuss it. So, I appreciate that Chris and Manisha kind of are taking a broader perspective on, our discussion. I'm certainly going to do this. So if you could hit the button there, Dan, my definition is simply commercial wireless services in the approximately 2030 to 2040 timeframe. So, this is IMT 2030 will certainly be a part of that, and whatever comes out of 3GPP to address the IMT 2030 requirements. But it's broader, as we've been talking about. So next slide, please, Dan. And really, as I look at the range of, sort of wireless offerings that are most germane to our customers, but I think, to most use cases, really, they fall into these broad categories. And I won't say it's a fully exhaustive list, but let's just, use this as a reference point. I noted earlier there was a question about, I think it was during the GSA keynote, whether fixed wireless access would be another important use case for, IMT 2030 technologies, and I think it will. I mean, I have a hard time believing that any of these use cases are going away in the 6G era. I think they've all, shown their value and will continue to have needs for them. It's really a matter of, what spectrum will best meet the need for each of these. So next slide, please, Dan. So some of the things that, I just wanted to tee up for conversation amongst the panel, and I'm really looking forward to the discussion because looking through the slides, I think we've got some really interesting perspectives in each drawing on different points. But one of the main points I would make is that everybody wants more spectrum, and a lot of the reasons for that is that we're at a point where yes, we can continue to squeeze a little bit more, a little bit more out of each hertz of spectrum. But one of the ways that we're predominantly, getting to greater and greater throughputs and these sort of headline numbers that people love to toss around is by going to wider channel bandwidths, right? So 4G, 20, maybe 40 megahertz, and then you can do some carrier aggregation. Now we're talking about every MNO needs 80 to 100 megahertz of contiguous midband plus whatever they've got in the low and the high. And similarly with Wi-Fi, we used to talk about 20 and 40 megahertz channels. Now we're talking about the need to go to 80, 160 megahertz, even 320 megahertz wide channels, Wi-Fi 6, Wi-Fi 6E, Wi-Fi 7, et cetera. So wider channels is driving a lot of this. Unlicensed and licensed still need additional spectrum to grow, no doubt about that. Fully agree with other points that have been made about the role that dynamic spectrum access can play. I think it's going to be critical going forward, quite honestly. We're getting some really interesting learnings from DSA in the 5G era, quote unquote, that I think will inform us going forward. And I think Manisha had some interesting points about what has worked well, what hasn't worked well, so we should discuss that. I think the point has already been made that we continue to move up, right? The definition of what's midband continues to move further up the frequency range, and to my mind, a part of this is that the focus on data services now. Everything is data, right? Voice is data, video is data. Everything really is data. It's making the higher frequencies more attractive because as we overcome the propagation and building coverage issues and things like this, it allows us to carry just so much more traffic because the channels tend to be so much wider to a point, right? So there is a practical point at which things are very hard to implement commercially, and I frankly think that's what we've seen so far with the millimeter wave bands. And it's one of the reasons I'm sure that eventually the terahertz bands are going to be very important to us. It's, to my mind, a matter of when that occurs. I'd make the point that I believe for the 2022 to 2030 timeframe, the focus will continue to be on ecosystem development on the cellular side in the 3.5 range largely, and then in the Wi-Fi ecosystem focusing on the 6 gigahertz range. And I think as we see the allocations that have been made, that's only logical. So spectrum increasingly valuable, efficiency, spectral and otherwise, and I think sort of licensing efficiency is something we should talk about, is going to be key. And then next button, please, Dan. So there's no way to meet the needs without spectrum sharing and innovation in licensing, for that 2030 to 2040 timeframe. I think that's, I don't really have any concern about that statement. Next slide, and this is my last one. I just wanted to tee up a few areas that, these have all really emerged to some degree or another, or at least been surfaced. But I think they're going to be, even more important as we go into 2030 timeframe. And, regulators need to be thinking about these in the context of spectrum policy and spectrum management. So software-defined radios, the ability for frequency agility, which ties directly into the whole dynamic spectrum access thing, that a database should be able to assign a radio to a particular operating frequency, AAS, and I know some people say that's adaptive antenna systems, or I think somebody else just used a different term, but most of the Googling I do tends to settle on advanced antenna systems, so that's what I'm going with. But we have these massive antenna arrays now, 64T, 64R type solutions. What does that mean directionality, as Manisha was talking about in the context of interference? use it or share it, right? So, some of the things we've seen with, the Ofcom model for reusing mobile allocations where they're not being used, the CBRS model, right? So just sort of almost an expectation if spectrum is licensed and not being used, it should be made available for other uses. Receiver standards, federal commercial bidirectional sharing, not just the feds sharing with commercial, but commercial sharing with the feds. Information sharing between services, right? So, Chris was talking about the need for real world data. Fully think that's right. And then we need information exchange between unlike services in order to maximize the efficiency and do real sharing. Flexible use allocations. So CBRS can be used for at least 5 primary different things, from mobile capacity augmentation to private networks. So things that can be used for lots of different uses are helpful. How do we address the in-building cellular issue, neutral host, densification, adaptive licensing? So, big licenses in the rural areas, small licenses in the metro areas in the same frequency range. And then how can we use the same infrastructure to address other issues that we have as societies, right? So in-building location is an issue. We have to, there's this huge safety issue around that, just, traffic management in our dense urban centers, et cetera, et cetera. I think wireless infrastructure can play a role in those things as well. So thank you. Look forward to the discussion.
Thank you very much, Dave. So I would now give the floor to Liu Guangqi. And I have a long list of questions for each of the panelists. So Liu, thanks for accepting this invitation, and please, we look forward to your points here.
Okay, thank you, Elena, and thank you, Dan's invitation for this panel. I think it's very interesting. I'm also looking forward to the discussion later. So first, I'd like to share some of my views on the spectrum demand and sharing towards the year 2030 for 6G. Next page, please. Yeah, for 6G, it's for sure it will target to support new service application and new usage scenarios. So it needs more spectrum, that's for sure. Regarding the spectrum for 6G, we, especially for the whole community, we need address 3 issues we are facing. The first one is how can we get the new spectrum, especially even with larger contiguous bandwidth spectrum. The second one is how to help the operators, mobile operators, to make full use of the different bands and try to to solve the support for different usage scenarios as it did, and also the different services. The third one, of course, is for the operators will always have the challenge on the spectrum, the traffic distribution, and how to support the moving traffic in the network. Typically, in the network, only 20% of the base station its traffic is very heavy, but the other 80% is quite light. For different operators, such kind of distribution could be different. So it's provide us a potential to share. If we can share this different spectrums among different operators, it's very possible help us to save some sites, save some base station, and also can further enhance the user's experience. Next page, please. To address the first issues we are facing, we need to make 6G to support the full spectrum access. That means 6G should support any new spectrum available for further future deployment. Just like Manisha and also the other panelists has mentioned before, we could consider sub 10 gigahertz. We could consider the millimeter wave, terahertz, even visible light. But for the early deployment, of course, we from our experience on 4G and 5G deployment, we do believe to further improve the user experience compared to 5G, 6G at least need 500 megahertz in contiguous 500 megahertz bandwidth for each carrier to guarantee we can provide 10 times user experience data rate, especially compared to 5G. So basically, sub 10 gigahertz will be a good candidate because it can provide quite good coverage and also quite large continuous bandwidth. For the other bands, of course, the millimeter wave, terahertz, invisible light, they can be used for the larger capacity and ultra high data rate for some premium application or services. And such bands can be switched on and off dynamically according to the traffic demand in the network. And thus, when the traffic is quite very light, these bands, space station, can be switched off completely, and thus achieve very growing network. Next page. To address the second issues, the multi-band coordination is necessary. By now, I think it's for the traditional mobile operator already have many bands for different generation, 2G, 3G, 4G, and 5G. For 6G, if we can have more bands for the 6G, that means we'll have for each operator they'll have more spectrum bands. For different bands, their capability and their link budget is totally different. So how can we really make full use of such bands and to achieve the compromise between the coverage and the cost of the network construction? It's really an issue we need to consider. Here, a direct idea is we can make full use of the low bands. For example, 700 is bands, good link budget to provide seamless coverage for the controlling, and the other bands like the 6 gigahertz, millimeter wave, terahertz, visible light, and so on, they can be used for the data links access. When the data traffic is light, such bands can be switched off. Then it's not just to provide to avoid the interference among different sites, but also it can save the share the processing hardware among different sites, and also save the energy of the network. And also, if we can avoid the interference among different sites, it can help to further improve the spectrum efficiency and also the user experience on the data rates. Next page. For to address the third issues, we have to consider the spectrum sharing, because the ununiform traffic distribution among different operators, among different services, or even different generation networks. The spectrum sharing potentially can help us to improve the spectrum utilization, especially for the spectrum lower than 10 gigahertz. For spectrum sharing, of course, it can be applied for not only licensed spectrum, but also the unlicensed spectrum. It can also be applied for different generations. So sharing for one operators, it can also be applied for different operator spectrum sharing, and also the different service like the terrestrial system, like the radar, like the satellite, and so on. Next page. Yeah, regarding 6G, I already consider the integration of satellite and the terrestrial system. So the spectrum sharing between the satellite and terrestrial is a direct direction for 6G. For example, we can share the satellites uplink for next page, please. So summary from the operator, from the industrial perspective, now we're already considered the spectrum sharing. By now, there's 3 types spectrum sharing in our mind. The first one, of course, we have good study and standardization in 3GPP. We try to based on the LAA and also the lesson before talk, we can use the unlicensed spectrum to help the IMT mobile operator to improve user experience, especially when the traffic load is very heavy. The second one, of course, is the network sharing from mobile operator perspective. This way could help to reduce the network construction cost. And also, if we can share the spectrum together, of course, we can further improve the user experience. For example, in China now for 5G, I think China Mobile, China CBN, we share 700, and for and also 4.9 gigahertz spectrum. And also for China Unicom Telecom, they share 3.5 spectrum. If with 200 megahertz bandwidth, of course, it can improve the user experience quite well. The third one, of course, is the cognitive radio. Try to build up some database, also some provided spectrum sensing to guarantee the spectrum usage among different services that can be possible. And also, the primary service will not be interfered. Okay, that's all my slides. Thank you.
Thanks a lot, Liu, for the very interesting presentation. Now, I already see some questions coming from the audience, and so I would like to open the discussion. And there are two questions that are addressed to all panelists, and one is directly delivered to Ofcom. So I will start maybe from Ofcom. So it's very direct to Chris. And here it was asked how Ofcom might help assure, let's say, this a consistent approach to international spectrum management within Europe that was already envisaged within CEPT. So how can this be provided in a post-Brexit environment? So CEPT already identified the consistent approach, and will it continue in a post-Brexit environment? What are the plans and the possibilities?
Thank you for that. So it didn't take long for the Brexit question to come up. So thank you very much for that. So, I mean, I think first thing, CPT, I think, has a very good track record of harmonizing spectrum bands. And I mean, it's what it's done for many years. I think it does it very well. And I would expect that to very much continue as the bread and butter of CPT spectrum work. I think what CPT does really, really well is react to how the world is evolving and ensure that we're harmonized across Europe. I think where we could perhaps do more, and this is perhaps what the question is getting, is thinking more strategically about how spectrum needs are evolving. I think we're trying to do that. We have a strategic plan for the Electronic Communications Committee, which I chair, and that sort of sets out, one of the key aims there is to promote spectrum sharing. And to do that by things like ensuring sort of technology neutral approaches, ensuring least restrictive technical conditions. We also work very closely with the standard side of in Europe with ETSI to ensure that we're enabling sort of spectrum sharing opportunities. So I think that's all work which will continue. And I think from a Brexit perspective, I mean, the CPT works very closely with the EU. So all the EU decisions are based on and actually replicate largely or almost entirely the technical conditions that come out from CPT. So in that sense, I think CPT will play the core role in terms of ensuring a harmonized approach for Europe, and I wouldn't see that changing going forward.
Thanks a lot, Chris. And maybe I would pass the second question to all speakers. So here somebody asked, to assure the quality of supply of spectrum globally, do we need a fresh approach internationally to anti-jamming policies? What does best practices look like? So do we have already some ideas about anti-jamming policies that might work globally? Who wants to take this question?
I can try. So I'm not sure what anti-jamming, what the question is really referring to. If this is malicious jamming, there is very little that spectrum regulators can do to prevent it. It is illegal. But we know that there are a lot of illegal activities that people indulge in anyway. If the question is more referring to, can we detect jamming better as we go into the future with newer technologies? I think that's definitely the case. There's been a lot of research done on using things like AI and machine learning to detect when a signal is being jammed. But more difficult than detection is actually tracking down where this jamming is coming from. And all of that ties into the enforcement that regulators need to do, which is actually a growing problem. I don't think it's unique to 6G. It exists today. One might say that it might get worse with 6G because now you're talking about more spectrum that could possibly be jammed. But yeah, it is an issue that regulators always keep in mind as to how they can track and locate interference.
Oh, thanks a lot. Any other comment on this?
Hello, Elena. I'd like to add something. Regarding this question, I think it's a good question, but actually, from the large-scale deployment perspective, I think the current situation is try to have some, a negotiation among different players and try to set up some constraint on the transmitter and receiver and so on. Also, even define some mask for the IF modular and so on. Such I think such is the kind of practice, because from technical perspective, I think if you can, just like Manisha has mentioned, if you cannot identify the direction or the site of the interference, it's very difficult to really to anti the jam.
Yeah, well, this links also to the third question that we received, because somebody asked about what is the potential in using AI to solve certain problems and helping increase spectrum efficiency and for future licensing ecosystem. So AI has a big role to play. So what are the perspectives and in different parts of the world, so in China, but also in the UK. So what are the possibilities and if this is being considered? I see that in the UK there are also these spectrum sandboxes being introduced. So what is the role to be played by AI systems in these future networks?
So shall I go on? So I think, as you just mentioned, we have these spectrum sandboxes, and I have no doubt that, come 10, 20 years time, AI will be playing a key role, I'm sure, in terms of promoting spectrum sharing. And we absolutely want to explore and enable that sort of innovation. At the same time, however, I think it would be completely wrong to sort of say, oh, we won't have spectrum sharing until we've got the AI solutions or the blockchain solutions that are in place, because that risks really sort of waiting a very long time. I think AI is something that's really interesting, as indeed a blockchain and other things, but it will take time for those to evolve, and we can actually get on and do quite a lot of sharing in the meantime. I just wanted to come back to the previous question as well, because I think the idea of sort of jamming and things like that. There is a limit to what regulators can do, but actually I think we can also do more and do some very straightforward things. For example, to cooperate together better to stop non-compliant equipment, including jammers, coming onto the market. And where sharing goes wrong at the moment sometimes, or where you get interference in shared bands, is quite often non-compliant equipment. And if we could cooperate together as regulators to actually stop that equipment coming onto the market, that would be a sort of a quick and easy-ish win, or easier win perhaps, in terms of how we can actually promote things like spectrum sharing.
Can I jump in, Elena? Yeah. So I fully agree with Chris. Right. So even the phrasing of the question, I was a little uncomfortable. How big a role I think it was, big potential. There's potential, and there's significant potential. How big it is, I think we'll see. But fully agree. We should not be waiting for AI to arrive to save us from our spectrum efficiency issues, because that's not the right way. Right. The right way is to get started, and frankly, we've already done that again with some of these dynamic spectrum access systems that we put in place. But again, I think as you think about, as information becomes available, Chris talked about the need for more real world information coming back in, right? And so I've got databases now that have some awareness of different incumbent services operating in the band. They're aware of these new radios that are coming in. They're where they're located, what powers they're operating at. We could extend that to like AAS awareness, right? Directionality, what their beamforming capabilities are, these sorts of things. And then, I think Manisha was pointing out, frankly, we're often pretty overprotective, with our propagation modeling and our assumptions and things like this. So, as I'm getting real world data back potentially about energy levels in the band, could I apply AI and ML to really optimize the spectrum allocations and the power levels at a certain location at a certain time, and do this management more in real time, so we get away from sort of the static mentality that I think Manisha was alluding to, even with databases, to much more advanced dynamic management of spectrum. I think that's going to be critical going forward.
Yeah, Monisha, you have some.
Yeah, just to add to what Dave and Chris said, I think so. The first point Dave alluded to, that any AI algorithm is only as good as the data that's used to train it and to develop it. And today, I think in our field of wireless communications, we suffer compared to say transaction data. So much of that is available today, or image data, or video data. We do not today have good databases of spectrum usage, and part of say the research that's going on, at least in the US, via centers like SpectrumX, is to address that need. The second thing, and having spent a little bit of time in the regulatory body in the US at FCC, the biggest problem I think that AI ML methods will face is in how do you certify that. It's very easy to certify a database for accuracy. You look at the models, you look at what input it's taking, and is it certifying. When you throw in an algorithm in there, and an algorithm that is supposed to protect maybe critical service incumbents, it becomes very, very difficult to test and certify these methods. And so those are some of the research problems that the community needs to start looking at, not just developing the next best AI algorithms that goes from 95% accuracy to 96% accuracy, but really thinking about, okay, how robust is this? How would an agency try to actually go there and build a certification program around it?
Yeah. Well, in this respect, I would have a question for Liu. And I think it would be very interesting to hear in this discussion about the lessons learned from 5G in China. And actually, how is this multiple type of networks integration going to look like in a 6G environment? And what are the possibilities, and how do you envisage that in a very sophisticated and complex environment such as China?
I think in China, setting is quite similar. I think from the regulator, I think they also want to touch such kind of topics, how we license the spectrums in a better way, and how to make full use of the spectrum, especially the spectrum efficiency. Just like Chris and Melissa has mentioned, I think they also want to get the data of the practical usage efficiency of each site. They even want to have such data. Then, based on this, they can consider some new business model, especially compared and consider the spectrum licensing, and also they also consider use some, especially for 5G. Do we need to license some dedicated spectrum, for example, for the private network and so on? But there's so many debate from different players, especially from mobile operator. Of course, we hope we like to provide such kind of service, but from the other players, just like Dave, such kind of company, I think you guys also say, okay, you should give the spectrum license to the enterprise, and they can just build up their own network and serve themselves and so on. But for 5G, I think a new start is on the network sharing in China, especially. I think it's a good start to consider the spectrum, because traditionally, I think for each operators we allocate dedicated spectrum. We cannot share. We don't have the handover each other. Even roaming each other, we don't have such. So each operator depends on their own network to provide the service. But for 5G, I think different operators start to share their spectrum. They try to have the compromise on the cost and also the performance of the network. So such kind of situation, I think we will continue to try something new to make sure. I think how can we just really get enough spectrum for individual use cases.
Thanks. And I have a question for each of you. I think it's a legitimate question because there are different challenges here. There are technical challenges. There are, about sharing and avoiding interference and so on. There are also some other type of challenges that are more administrative type. So I'm wondering, we're talking about the next generation networks and technologies and so on, but I'm wondering how regulators, especially in developing countries where regulatory authorities are either don't have the technical skills or the resources to really address this new type of complexities. How do you envisage this challenge, and how could it be addressed in other markets? Think of countries that are developing very fast, a lot of opportunities for industry and so on, but still challenges from the regulatory perspective to modernize and to have the right tools. So maybe Chris, you can open the floor based on your experiences with in dealing with other regulatory authorities and so on.
So it's a very good question. I mean, and I think it is difficult because different countries are in very different situations. But I think as a starting point, my suggestion would be not to overcomplicate. And I think particularly when it comes to spectrum sharing, there sometimes is a tendency to look for sort of complex technical solutions when actually I think what's required, I mean, the need for basic information, I think, is fundamental. And actually getting that basic information into the public domain so that people can actually see how spectrum is being used. And then probably at the most basic level, just thinking about sharing at a geographic level. I mean, particularly as we move into the higher frequency bands that we're talking about at the moment, whether that's in the mid band above 6 gigahertz or in millimeter wave or sub terahertz, you're not going to see rollouts at national level. There's actually going to be quite large geographic areas where there's potential for sharing, and just having that information that's available so that people can actually see when and where spectrum is being used, I think would be a very good starting point.
Yeah, well, I think maybe Dave, you can add something. You mentioned about adaptive licensing models and usage or sharing. So what is your view on this in less developed markets?
Right. Well, and it's not just a less developed market issue, right? I mean, there are perennial issues that we have been talking about now for decades that continue to really go unaddressed, and they can be even more sort of blatant, if you will, in some of the developing markets. But there are issues in the first world as well, right? So rural connectivity, and then socioeconomic connectivity, for the less advantaged people in society as well. So I mean, Chris and I were just at a conference earlier this week where we continue to talk about, okay, how do we provide coverage in areas where it's really just not economic to put fiber, potentially put macro towers and things like this in when the return just isn't there commercially. So I think I'm really interested to see the advent of all of these new low Earth orbit satellite broadband systems, and can those get to a point at a cost per bit per hertz, kind of per area level that they really can provide affordable and reasonable broadband service, sort of irregardless of where you are on the globe. I mean, I think that could be a significant change in that issue. So I'm really looking forward to that. But I think that the cost issue is always there, right? And that's, again, I think why you need to look at sort of the panoply of solutions from a wireless, in the wireless offering space. And frankly, when you're paying billions of dollars or euros for spectrum at auction, it doesn't necessarily, it's not easy to translate that into providing an affordable service in a rural area, right? So I think, the role of unlicensed spectrum, use it or share it. Okay, the mobile operator is paid the billions of euros for this spectrum. They're going to deploy it in the metro areas along the major transit corridors, et cetera. But out in the middle of nowhere, they're probably never going to deploy that mid-band spectrum. So are there ways the regulator can then make that available for other, community networks who might want to deploy it and use it? And, what does that look like? How do you give them some level of assurance that they'll have that spectrum? What if the MNO decides they want to deploy there later? So those are the kinds of things I think we could be thinking about.
So thanks a lot. We have our last 10 minutes just to wrap up this session. So I would like to ask, each of you to just say what are the key takeaways from these discussions and what are really the next steps in your opinion, but just in 1 minute each so that then we close. So we start from Monisha.
Thanks, Elena. If I may, there's one question in the chat about receiver performance requirements. If I may address that as part of my response. So I think that is very, very important. Better receivers make better neighbors. So sharing in spectrum is definitely enhanced if you have better receivers. In the US, the FCC recently had a notice of inquiry on receiver standards. The outcome of that, and there were a lot of responses to that notice of inquiry, was that everybody thinks it's a good idea, but nobody wants rules. Nobody wants the regulator to tell them how to build better receivers or what they should be building, because it does limit competition because of increased costs. So that is an area which is continuing to evolve. There is more attention being placed on receivers, especially legacy receivers. How do you allocate new spectrum adjacent to spectrum where you have very 20-year-old receivers employing very old technology? So all of that are very challenging questions. So in closing, I think what I would the message I'd like to get across is that, as we look forward to the next 10, 20 years of wireless, there is an amazing amount of technology evolution that is going to happen. It's a very exciting time for researchers. We need to focus on, as a community, I think we need to move away from this idea that there is licensed spectrum and there's unlicensed spectrum, but instead develop systems natively to share. So there's a lot of talk of developing 6G to natively implement AI. I don't see any talk about developing 6G to natively share. I think those are some of the priorities. Things like AI, ML will play a big part. But then the standard device technologies that allow us to go up to higher bands will also continue to work.
Thanks, Monisha. Chris, next steps, what do you think?
So firstly, I just wanted to agree with Monisha on the receivers point. I think, receivers do need to be addressed. It's not easy, but we've seen too many cases where poor quality receivers have effectively been very much hindering efficient use of spectrum. And I think that's something that, there's lots of high profile cases around that. And I think that's something we just need to find a way forward in relation to that. In terms of summing up, I think that the fundamental for me, and again, I like Monisha's comment just now, that we need to get away from thinking about licensed and unlicensed spectrum. It's one or other. It's not one or other. We need to think much more creatively about how we make spectrum available. And we need to sort of change the mindset of everyone so that people can think about spectrum sharing as the norm. It's not just license exempt or unlicensed spectrum. It is, spectrum sharing needs to become the norm. And given the scarcity of spectrum, we've got to find effective ways of doing that. And we've got to get people to actually think that that's the way they want to move forward and accept that actually they do need to share their spectrum, and they think about how they can do that rather than try and put up barriers, which is what we sometimes still see when people think about sort of exclusive spectrum rights and things like that. So I think it's about changing mindsets.
Thanks, Chris. And you?
Okay, thank you. I'm from the mobile operator, so from my perspective, I think for the whole community, I think the consensus is very, very important, especially for the licensed or shared spectrum, and also the band allocation for future, especially for 6G. The earlier the better. Only when we have the consensus, then we can try to reduce the burden to the network and also to the devices. Then it will be very helpful for the 6G development.
Thanks. And Dave, next steps, takeaways?
Yeah, thank you. I'm going to loop back to the receiver standards as well, just quickly to say, I think we have to get started, right? Yeah, Manisha mentioned the NOI that the FCC just conducted on receiver standards, and I believe there was another study conducted like in the early 2000 timeframe on this, and it basically didn't go anywhere. And my concern or my point would be, maybe if we'd enacted something about receiver standards in 2003 or whenever it was, we might have a generation of receivers at least coming into the market now, if not prior to now. That would have, had these capabilities. I mean, some of these systems that are out there, right? DoD and aviation, et cetera. I mean, they have decades-long life cycles, right? So if we don't start doing something about the receiver standard issue, we're going to have equipment out there in 2040 that's still going to be presenting problems. So we need to do something about this. That's my soapbox there on receiver standards. Key takeaways, I fully agree with the other panelists that we need to kind of move beyond this bipolar licensed, unlicensed paradigm. There's, that age is rapidly coming to a close. And so with the advent of, dynamic spectrum access, adaptive antennas, the flexible use licensing, there's no reason you can't, put protected access and opportunistic access into the same frequency band, even under the same regime, and just manage that. I do, again, I think we put out some of this is really going to change, or it's going to require changes just in philosophy of spectrum regulators and policymakers. So, they need to start embracing that. They need to start thinking about, the challenges that Manisha was alluding to. How do you certify an AI orchestrated spectrum management or coordination regime, right? I mean, I set some minimum protection thresholds, and then I let this thing go crazy above that. I mean, just how do you do that? And frankly, let's find some low risk bands and get started and iterate. So, yeah, 2030 will be here sooner than we know, and we're not going to meet the needs. As I said, we're certainly not going to meet the needs if we don't figure out how to do the sharing well.
So a lot of work to do in the next few years about 6G to prepare. And so I would like to close the panel here. I would like to thank again the panelists here, and thank also Forum Global for hosting this 6G Global Summit. Thanks to everyone, also on behalf of Calen International. And let's be in touch. Thank you.
Thank you.
Thank you.
Bye-bye.
Elena, thank you very much, and my thanks as well, of course, to the panelists, to Liu, to Dave, to Manisha, and to Chris, and as I said, Elena, to yourself as well for moderating that session. So thank you very much as well, and thanks to everyone in the audience for your comments and thoughts as well. Really interesting discussion, and one that I'm sure is going to continue for a long time. So really enjoyed that discussion. So thanks very much, everyone. So those last two sessions, we've had a good focus on connectivity and on spectrum, and as I said, that's definitely a conversation that is going to continue, I'm sure. But now we're going to switch the attention. For the last session of the event, we're going to be looking at something that actually was touched on quite a few times, I think, during the discussions yesterday, and that is looking at 6G for good and looking at kind of sustainability and looking at kind of how societal goals can be kept right from the start at the center of 6G development. So we're going to be starting that session very, very shortly. We're actually going to switch just to a different studio. So please don't go anywhere. Stay where you are, and we're going to be back to start that session here on the main stage in just about 30 seconds or so. So we'll see you very shortly. Thank you.